Good afternoon, everyone. I'm Renee Cannon. I'm a sales engineer at InterSystems, and it is my pleasure to welcome you here this afternoon for a session on Smart on FHIR, the basics. So what we're going to do today is talk about different standards for healthcare information technology and talk about how all these different standards over the years really point toward FHIR. And then we'll talk about how an organization has leveraged FHIR to solve new types of interoperability problems. And we'll talk about how InterSystems brings FHIR capability to your organization. And we'll also talk about where InterSystems is going insofar as developing even new capabilities for FHIR. Now, this is Smart on FHIR, the basics. This was the first of a series of 3 FHIR sessions that were created for Global Summit. One talked about basically how data flows through HealthShare when using Smart on FHIR. And there was also another session that talked specifically about how to launch Smart on FHIR applications when using InterSystems products. Those sessions have passed, but those recordings will be available. So feel free to, think of this as a starting point, and then you'll want to see the session about the FHIR gateway, and then also see the session about launching Smart on FHIR apps. And there was, in addition to these sessions, there was an experience lab for that, and that will be made available post-summit as well. All right, so the things we're going to talk about today are mostly trademarked. These icons that you see up here, these are representative of standards and organizations that really are the result of many, many people over many, many years dedicating their entire careers to trying to make sense of the way we record data when delivering healthcare. And so some of these ventures were for profit, other ones were voluntary. Some are liked more than others. But really, because of the work all of these people have done, it's made the lives of us and the people we love so much better. And so here's just a shout out to all the people that have given so much and have benefited all of us. Okay, so when we talk about health data interoperability, it's a wide field, but we can kind of break it down into different types of things. We, of course, first start off with just how we simply describe things. What does it mean to measure blood pressure? What does it mean to measure temperature? How do we want to describe things that seem to go logically together when delivering healthcare? So those data standards work with messaging standards, which is how you determine how the data will be moved back and forth between systems. And then there are ways that data is organized together and sent across with messages. And then there's other standards that don't really fit into any of those aforementioned categories. I'll give you an example of that. But then last but not least, you find that organizations get together and they review what's come before them and figure out, based on what they've done before and based on what they see going on in different verticals and also state-of-the-art for technology, what should the direction forward be? And you'll see that FHIR is an excellent example of that. So we can kind of graph out the evolution of standards. Down there at the lower end, you see the evolution of data standards. It actually started right at the beginning of the 1900s when medical practitioners decided that, rather than just simply issue death certificates when people passed away, they wanted to categorize the cause of death so that they could kind of see what the trends were and see, how certain things were affecting those outcomes. So ICD originally was a classification for causes of death, but over the years it's grown to become a way of describing diseases, injuries, disorders, and other types of things. So that data standard is complemented by CPT, which is used for describing procedures. And then SNOMED comes along, which gives us language for describing pretty much everything you can think of in the field of medicine. So these 3 data standards really is the beginning of our healthcare IT standard journey. But then HL7 comes onto the scene. And what HL7 realized is that with the advent of computers being used and delivering healthcare, they said, we better figure out a way to get all this stuff organized because different groups are describing things in different ways. They're piecing that data together. They're sending it over to other organizations different ways. Let's see if we can come up with a standard to kind of make everybody's life easier. And then you also see other ways of doing things. Art and syntax is an example of a standard that really didn't fit into either one, and in fact is perhaps the first example of process standardization. Art and syntax is a way of creating modules that can be executed by clinical decision support systems. So again, it's not quite a messaging standard, not quite a data standard, but it's beginning to complement and fill out all of the things we need in order to exchange health information data effectively. LOINC is for describing healthcare measurements. And then IHE profiles bursts on the scene and says, okay, we've got data standards, we've got messaging standards, and we've got some things that fall in between. What we really need to do is be very specific when we talk about how we have clinical outcomes with data. We need to be specific about which data standards are used in which circumstance, what actors are used, and which transaction are used in order to do this. And so IHE profiles has been very effective at doing that because it gives a rigidity that everyone can agree to so that, again, they can meaningfully exchange data about labs, meaningfully exchange descriptions of patients, so on and so forth. CDA is a fine example of where HL7 began to look at what was going on with technology. Whereas previously you don't really see much use of markup languages that could be read by machines as well as by people. But with clinical document architecture, they said, okay, we'll set up some rules for describing a medical document, but then we also want to look about things that make things machine computable and also make them more human readable. But CDA continued to evolve, and then when HL7 version 3 came along with specific data types and information models, then CDA leveraged some of the innovation that came along sooner, and that's kind of where CDA is today. It's sort of considered to be a flavor of HL7 version 3. And then last but not least, sort of rounding out our curve, is XDS, and the purpose of that is to describe how data gets exchanged between enterprises. Kind of everything I said before is like maybe ways you could exchange within, and everybody has their own practices for their health IT, but what XDS gives us is a prescriptive way to exchange documents between enterprises. And so I imagine with having described data standards and messaging standards and some process standards, we've solved the interoperability problem, right? We've got everything we need to do anything we'd want to do, or do we, right? Wait, there's more. So in order to understand what was missing, let's talk a little bit about HL7. I bet a lot of people just know all about HL7 but don't know what the 7 stands for. 7 is sort of the pinnacle of this way of modeling how application infrastructure gets built. So that's what the 7 means. HL7 has been around for a while. As like I said before, they were the ones that first said, all right, we're getting data standards. We need to kind of figure out how we put this data together and send it in between these computers that are starting to want to communicate within the healthcare network. So they've been around for a while, and they've developed several versions over the years. And here's a picture I drew to just kind of show how the versions have evolved over the years. So we start all the way on the far side, and you see at the top HL7 version 1, which is just a proof of concept, followed by HL7 version 2, and then you see continuing along version 3, CDA, and then this guy here on the end. This is really not meant to be a detailed study, but what I'm trying to point out is as HL7 evolved, they carried some characteristics forward and they discarded others. A simple example of that is non-XML documents were used in the beginning, right? The pipe and character that we all know from 2.x. But now once you get into version 3, now you're seeing things like XML documents. And another example is in version 3 of HL7, context is implied. You sort of look at the patient that's in there and you figure all the other things in there have to do with that patient. But as you'll see, FHIR is very explicit about context, and that really helps to enrich the ability to exchange data at an individual resource level. So when we describe HL7 version 3, when you look at that picture, it seems like, again, everything's there we need. We've got data standards, we've got messaging standards, we've got profiles, and so when version 3 came out, we sort of assumed everyone was going to use it, right? Because we've now got everything we need. But in fact, that's not what happened. You really only see version 3 like widely used by big organizations with big budgets and big teams and things like that. And so they went out and asked some people, well, you guys are using version 2. Why don't you just jump on over to version 3? So organizations came back and said, we spent a lot of time and money standardizing on HL7 version 2.x. And I think VA, U.S. Department of Veterans Affairs, is an example that is a heavy user of 2.4, even though there's version 3 out. But when they asked organizations, well, we came out with version 3, it can be rendered in a browser, it's got all this great stuff, why didn't you do it? And it basically boiled down to 2 things. It's too expensive to get there, and it's too complex. And so the value, what they would gain moving from 2.x, it just wasn't worth it for them. So the U.S. Department of Health and Human Services asked the JSON task force to kind of look at the industry, look what have we done before, what's going on now, and where are different verticals going, and help us understand why, unlike other technologies that have emerged and have been widely adopted, how come people aren't jumping on the bandwagon for things like HL7 version 3? So the JSON task force came back with like a 20-page report, and they were very clear about what they saw the problems being. One is, just sort of having an outdated approach to doing things, and they were a bit frosty in their comments, and if you read the report, you can see some pushback. But it is true, there were reasons why version 3 didn't become sort of the grand finale of all health information standards that would ever need to be adopted. But JSON Task Force even went the additional step to saying, we've been looking at what's going on, and we think we know the way forward. And so in a nutshell, what they're basically saying is you guys need to think about making things available so that people that are developing new software can have an API-based approach instead of the way that they've gone traditionally. And I should also mention that in that report, you'll see they make repeated mention of a particular data standard for implementing that public API. And I bet everyone in here can guess what that is. But I'll give you a hint, right? So the people that worked in the HL7 organization got together. This time, unlike before, where certain versions were really led by either interface developers or clinical informaticists, what they did is they said, let's talk to all the stakeholders in health IT, and let's figure out what it's going to take so that we can come up with a standard that has broad appeal. So they talked to developers, they talked to architects, they talked to people in the C-suite. Conversations got them all together, and they kind of came up with a mantra. So I should say, disclaimer, this is not an official HL7 statement, but if you look for sort of their manifesto of what they always had at the forefront of their mind as they developed this new standard, which I'm about to talk about, these were the things that were most important to them. And in a nutshell, they boiled it down to, make it a cost-effective standard with wide appeal, where those skills are readily able to be used, and we can sort of get everyone to agree to enforce them. And the standard they came up with was, surprise, surprise, FHIR. FHIR is an acronym. FHIR is a data standard that is owned by HL7. Unlike earlier versions of HL7, the FHIR specification is widely available. It's extensible. You can go online and get all the information you need, including samples, and all the explanations. You don't have to pay to play when it comes to HL7 FHIR. So what is FHIR? It's a new standard for exchanging health information electronically. So what they did is they, again, not only looked at what had been done in health IT, but they also looked at banking, they looked at manufacturing, and again, they looked at the state of the art for the internet and said, okay, let's do this the way all these stakeholders would expect data to be exchanged nowadays. And so when we talk about interoperability, whether it be syntactic all the way to the pinnacle, which we'll talk about later on, where FHIR fits in the interoperability spectrum is semantic interoperability. That being that when you're sending data to another system, this data is described sufficiently so that the target system will understand what's being received, and the target system has decided what it's going to do when it receives that. The thing I want to point out, though, is this FHIR specification does not dictate how those systems interoperate. It just dictates that this data has to be meaningfully described. So I imagine some of you are familiar with FHIR. If you're familiar with FHIR, if you're just getting to know FHIR, there are some core concepts that you can kind of start off familiarizing yourself, and then you'll get a real sense of how FHIR works. And so we'll just briefly go through those. FHIR resource is a granular clinical concept. You can have something like a patient resource, or a medication resource, or an allergies resource. Those granular clinical concepts consist of properties within them that sufficiently describe them so you can understand what they are. And so they are described per the FHIR standard, but they're also extensible. So again, I work with the U.S. Department of Veteran Affairs, and the way they deliver healthcare has a lot of specific types of health data that are really relevant only to people that have served in combat or people that are getting benefits through different channels. So it's not sufficient for them to use a standard model to adequately describe the people they deliver care to the way they need to describe them. So something like FHIR is attractive to them because it has a nice core standard, but is fully extensible. Another thing to notice about FHIR resources is that they can be autonomous because they're fully addressed, and they can also reference other resources. So let's just quickly go through what one of these looks like. So as an example, we're going to talk about sort of the basic set of properties you need to describe an observation. So our observation is going to be in the vital signs category, because obviously there's all types of observations, and we're specifically going to be measuring the heart rate as a type of vital sign within the category of observations. And so there's some coding standards associated with that, and also, descriptions of the units of measurements that are used. And so once we have an understanding of that, then we begin to put together the pieces that go into building, in this case, a FHIR observation resource. What you're seeing here on the screen is actually JavaScript object notation, aka JSON, and these are little bits and pieces of what an actual FHIR resource would look like if you were seeing the JSON representation of it. You could also see a FHIR resource in XML, or you can see it in Turtle, which is part of resource definition framework. So we've said this FHIR resource is of type observation, so you immediately have to have things like the observation declaration of the resource. It has to be uniquely identified on the server that would be serving out that resource. And then in order to be clear about what type of FHIR resources is, then you declare which FHIR profile that resource conforms with. In addition to just simply declaring our observation resource is an observation with an ID, we're now beginning to be specific about what type of observation is. So we first narrow it down to a category. So heart rate is a type of vital measurement. So now we're saying that our observation is within the category of vital signs, and similarly to the way we had our FHIR profile for the observation, we also indicate which category that this resource is in. And naturally, we continue along to finally narrow it down to the very specific declaration of that this is a heart rate. So we say this is a heart rate, and for the LOINC coding system, which we've declared here, we indicate what code that is. There's only one thing missing, right? And that is the actual measurement itself. So in this case, this heart rate observation is a value of 127 beats per minute, which is right about what I'm running. So we can indicate what the value is, but then we have to say what the units are, beats per minute, and then, again, similarly to everything that came before it, units of measurement, where that system comes from. So you notice the beauty of that consistency, right? That you're saying, okay, this is this part of this type of FHIR resource. This is the profile that it complies with. So let's put it all together. In the case of again, a JSON representation of it, this is kind of what it looks like. And all that stuff that we kind of walk through is spread out throughout here. They don't have to be in, these different aspects of properties don't have to be in a specific order. I'm about to mention, so the one instance, the primary instance where order does matter. And that is when we sort of get into FHIR bundles. Remember I said earlier that because FHIR resources are fully addressed, and you can uniquely identify them at up to server scope, right? Then you can do things like put them together, and you can still distinguish them. And so here's an example of where I've bundled a bunch of FHIR resources together. And notice there's no rules about how many you can have. You put them all together, and because they're individually addressed, I can always get at one. But it's also interesting to note that these can refer to another, right? So an allergy might reference a patient. But when an allergy references a patient, then that actual resource that it's referring to may or may not be in a bundle. So imagine you've loaded a patient resource onto your FHIR server, and now you're loading allergies because that person came in and it was determined they have a new allergy. So you don't have to reload the patient resource. You can load the allergy resource and point to the patient resource that's already on the FHIR server. Now, these FHIR bundles can just be a bunch of resources bundled together, but let's say you want a context, right? Because you're trying to make some kind of a statement, like a given patient's health record. So what you do is you use something called a FHIR composition, which in and of itself is a resource and must always be the first resource in a bundle, but that's kind of where you say, this is no ordinary, bunch of resources. In fact, there's a significance, there's a context of this bundle of resources. And so you use a composition as the first resource in the bundle, and it tells you something about what's in there. And document is a fine example of a bundle that has a composition in it to say, hey, this is a document that's a bunch of resources bundled together, and you'll notice here, they may be clinical or they may be non-clinical. The standard for FHIR, again, kind of encompasses everything that has to do with healthcare. So you can have things bundled together, and it can be anything from a patient care record to things like practice guidelines. You can have different types of FHIR documents, clinical, non-clinical, but there are some rules about how a FHIR document must be structured. Primarily, that composition has to go in the beginning, and that composition is basically going to say, here's the significance of it, here's what's in here, and then you'll notice that there could be in that bundle things that have to do with styling, signatures associated with it. So, but the most important thing is if there's some context, or if this is a FHIR document, that composition resource at the beginning of the bundle kind of tells you what's going on. So I hope I've really whet your appetite for FHIR. And maybe the burning question in your mind is, how do I create a FHIR resource? How do I read a FHIR resource? How do I update a FHIR resource? How do I delete a FHIR resource? How do I search for a FHIR resource? And how can I validate a FHIR resource? These sorts of questions, this CRUD, with search and the ability to validate attached on, these are called FHIR interactions. So it's basically the ability of a FHIR client, which is going to be RESTful because the FHIR standard requires that. RESTful client is basically asking a FHIR question of a server. Either I want to put something there, or I want to search for something there. So for a FHIR resource that is supporting these FHIR interactions, it's not required that the FHIR server support every possible interaction like the ones I've mentioned. And it's not required that the FHIR server support every resource through all of those interactions. But it must tell the FHIR client what it's capable of doing. And so that statement is called conformance. By the way, this is the only time you ever want to see your server on FHIR, and that's because it is serving FHIR, right? And in the process of serving FHIR, it has to include a conformance statement that says, hello, I am a FHIR server. These are the interactions I support, and these are the type of resources I support. All right. So I mentioned earlier that the JSON task force, when they released their report, but it is worth having a read. As the reports go, this one is pretty good because there's a little bit of drama in it, and you can get like a little pushback from people that read it. But it really shows vision on their part. And they looked at what was going on before with standards, and they looked forward of where they saw the world going, and they knew about this thing called FHIR, and they saw that FHIR would really lend itself to a type of API, again, that would ultimately have broad appeal. So back in 2014, when that JSON Task Force report came out, they were specific. They had a possible implementation, and you'll notice they specifically call out FHIR in there. And it's okay to understand this. The thing that jumps out at me is there's FHIR everywhere, right? They really saw this as a very versatile standard that could handle the different types of things you'd want in an API for solving a whole variety of interoperability problems. So if you're a fan of InterSystems technology, you'll be pleased to know that as of Health Connect Core 1501, we have the capabilities in there for doing FHIR interactions and storing FHIR resources. So at the beginning, we talk about having the ability to accept and respond to RESTful requests. That's the things I just mentioned with SCRUD and validation, that HealthShare can be that FHIR server that understands that RESTful client that sends in a message, wants to do something or wants to search for something. You have all that built into Health Connect and therefore HealthShare Information Exchange that knows how to do that. Similarly, if you need your HealthShare system to consume FHIR or emit FHIR out to another system, HealthShare can be a FHIR client that will go and talk to another RESTful server. We'll go talk to another FHIR server through RESTful requests and do a FHIR interaction. Now, in order to have a FHIR interaction, you need to do that through RESTful service, and there are messages associated with that. And within HealthShare is all of the definitions of messages that support those different types of interactions. Now remember, through those RESTful interactions with a FHIR server, you're exchanging data, and that data is FHIR resources, FHIR bundles, and things like that. So within HealthShare is a full object model that supports the FHIR resources. And just like the FHIR standard is extensible, so are the FHIR resources in HealthShare. So you can go in there, add your extra fields. And I know there's this whole thing about if you're going to extend like standard FHIR, you want to register your FHIR extensions so that if somebody wants to exchange data with you using your extended FHIR resources, they need to understand what those look like. So there's the ability to define them in HealthShare, and there's infrastructure out there for being able to register your FHIR extension so other people understand how you've extended that standard. And then last but not least, the resource repository. So imagine the use case where you've got a mobile client and you're at you're at CVS and you want to get your allergies just to make sure. But if we were still in the world of HL7 version 3 and you wanted to get your medical record, it would give you a CDA, all of it, right? It's like drinking from a fire hose. But because FHIR is uniquely addressing every resource in there, then it becomes really easy for FHIR Server to just emit those resources that the RESTful client requests. But still, the idea of trying to shove all the allergies into a cell phone is a bit of a task. So what HealthShare provides is a resource repository within the HealthShare infrastructure so that you can cache FHIR or you can persist FHIR, depending on what your use case is. And so imagine if you want to just have for a session where these FHIR resources are going to sit there while the cell phone pulls them down or maybe browses to another part of the person's clinical record, you've got a resource repository. The reason why I'm harping on this is this really helps to avoid a complex middleware problem, right? Imagine if HealthShare, yay, HealthShare's got a messaging model, it's got an object model, but I got nowhere to put this data while I'm trying to serve it out to the client I'm having a FHIR exchange with. But because the repository is built into HealthShare and has all the scalability capability of the cache database, then you have the beauty of having what you need to cache FHIR while you're serving it out. And it's fully compliant with FHIR Interaction. So if you want to persist FHIR resources there, you can. And search capability is on there as well. I think you have to create your own validation, but because the object model is on board, you just validate, right? For people that are used to using cache objects, you kind of know how that's done. It's already right there. Last but not least, of course, for people that use HealthShare, there's a canonical form of the data inside HealthShare called the summary document architecture. And so HealthShare provides the transforms to and from SDA to FHIR, and those transforms are extensible, and they're graphical. So it's kind of easy to take a look at them and add what you need if you have extensions on your FHIR resources. If you're using HealthShare Information Exchange, then you can now use what's called the FHIR Gateway to get at a composite record that HealthShare Information Exchange has built for you. So in addition to some of the other capabilities that are unique to Information Exchange, those sort of become available to you through FHIR Gateway. And the repository that's associated with this has a session duration. So let's just say you've got a client that just wants to now get a composite medical record as a FHIR bundle, then what will happen is the system behind the scenes will go and pull that and put it into its, again, session duration FHIR cache and then serve that out to you. So I just want to make that distinction between the fact that with the FHIR repository that we talked about in Health Connect, and of course therefore in Health Information Exchange, you have the ability to persist FHIR as long as you want. But when you're talking about pulling a composite health record through a FHIR gateway, then that caching of that is for a session only. And I'll talk about FHIR IHE profiles. I've got a slide on that. Okay, so we talked about what FHIR is, and we mentioned that FHIR, it describes everything meaningfully that you would exchange between systems, but the FHIR specification does not dictate how the systems will behave with each other. So that means there is something missing in interoperability, and that is business process interoperability. So business process interoperability is this idea that it's, we're not just like defining the data and the messaging between them, but now we're getting into how business processes will interact with each other. So there's a group that took the FHIR standard and then they began to add some rules around it so that you could have an open specification for exchanging information between health IT systems like EMRs, health information exchanges, portals, and things like that. And so what Smart on FHIR does is it takes the FHIR standard and then it adds rules for how authentication is done, how authorization is done, and then also some things that relate to the user experience, like specifying HTML5 and so on. And so that is how Smart on FHIR is the next step past the FHIR specification so that business process interoperability can be achieved. So let me see if I can convince you that that's a really actually powerful thing in the practical world. So imagine here, this is the medical chart of an 8-year-old female. And so every year her parents bring her in to the doctor so that they can do her checkups. And one of the things they track for children is how their growth is progressing. How's their height progressing? How's their body weight? And then when you do some calculations, how's their body mass index looking? So as you know, nowadays, when it comes to meaningful use, it really is about driving outcomes as opposed to just paying doctors for the work that they do. So health delivery networks are really incented to get good outcomes. And one of them, of course, is to maintain normal body weights for children and things like that. So as a doctor that has this patient in the office, if there are issues with maybe body weight being out of range or maybe their height having some issues, then if they're trying to explain that to the parent, I mean, they could look at the raw data there and maybe plot it out on a napkin, then maybe open a book that has the CDC chart of what normal ranges are by age range and things like that. But that's not nearly as powerful as being able to visualize it like this, right? So here's an example of where I've taken that data for height measurements and things like that, and now I've superimposed those measurements on top of what the CDC research shows as typical ranges of height and weight for children from ages 0 all the way up till 19. So this is way more powerful. But we've had data visualization for years. This, in principle, that doesn't surprise us. This is, of course, is a good thing to have. And many people have it right in their EMR. They can plot data. They can superimpose. What's really terrific about this, though, is that these applications, like the one you see here, are freely available very often, and they're being created by all types of organizations in health IT. So this growth chart is actually a growth chart created by Boston Children's Hospital. And when Boston Children created this, they complied to those rules for smart apps. And so what they did is, they used the specifications for authentication, authorization for the type of user experience. And because they followed those rules for creating the apps, those other applications that also play by those rules are now able to readily leverage these, right? You can snap these in to other applications because everyone's agreed to play by the same rules. And this methodology has wide appeal to all those stakeholders we saw before, right? If you're a developer, you're pleased because you need, once you've learned OAuth 2, once you understand OpenID, once you understand HTML5, you can be cranking out all kinds of apps, knowing full well that anyone out there that also plays by these rules can snap in the app that you've built, right? This is also appealing to architects because when they think about new apps that are being brought into the enterprise, how do I make all this fit with everything we've worked so hard to achieve? So because they understand the rules by which Smart on FHIR plays, then they now know what the expectations are. Okay, my IT director wants to use this new app. I'm good because I implemented OAuth in my enterprise and I've got OpenID Connect working. I can just snap in this application as well. And then obviously in the C-suite, there's great appeal because you're now delivering new tools that help doctors deliver care, and you're doing it in a way that's cost effective because you've now invested in learning this tool set and deploying it in your enterprise, and now you've got apps coming in that can use what you've already built. So it has, again, broad appeal everywhere from the developer all the way up to the C-suite. And there is indeed a big marketplace for them. If you go out there, you'll see there's individual organizations like the EMR vendors. Epic's got one, Cerner's got one, Allscripts got one, where they've had Smart on FHIR apps that they're building, or FHIR interfaces that they provide for developers. They're all in the game. And then consortia out there like HSPC, and then of course Smart. They've got their galleries of applications. So if you go to this apps.smarthealthit.org, what you'll see is a whole gallery of Smart on FHIR compliant apps broken down by categories, and you can scroll through them, you can pick them, you can test them in most places. And in the case of that growth chart, you can actually download the source code and go to town with the confidence that as long as I've got OAuth and I've got OpenID and my app can understand HTML5, I can readily use this. So again, it takes a lot of the guessing and uncertainty about, I'm going to invest all this time in trying to get this thing to work. As long as you play by the rules, you can reasonably expect you'll be able to snap that right in. So what do we provide in HealthShare? We basically provide two things for people that are interested in Smart on FHIR. We provide the ability to snap an app like that growth chart into the HealthShare Clinician Viewer. Or let's say you're building an application, you want to be able to launch it standalone, you have that capability as well. And if you, Gary did his section this morning, but again, that will be available. If you go and review that, you'll actually see him talk about how you configure HealthShare to launch that, that growth chart app I just showed you, and he also does a cardiac risk application. And if you want to understand more about the architecture behind Smart on FHIR apps or the FHIR standard, then there were a couple sessions earlier this week that talk about the FHIR gateway architecture for Smart on FHIR. And also how the data flows through the system. That happened as well. And again, because the sessions are recorded, you won't miss out. All right. So the goal of HealthShare when it comes to FHIR and Smart on FHIR is to give the ability to snap in data, right? If you've got health information exchange, you can snap in a composite health record from all your data sources into a Smart on FHIR application. Again, using that growth chart app as an example. Imagine that 8-year-old female had been measured all over the place because she's military family and everybody moves around. Once she has her composite record, then it's easy for the clinician and easy for the parents to kind of see how their child is progressing. And then for snapping in GUI, if you're building applications, you can snap those in. So you have a choice, whether you're providing data or providing applications. That HealthShare supports the choice that you make. I mentioned FHIR profile support in HealthShare. So remember, profiles are that sort of body that says, okay, if you're going to do this, then you need to have these actors, these transactions, these standards. So once FHIR became more widely accepted, then the IHE profile group said, well, FHIR's cool, so let's build some IHE profiles that are really specifically relevant to the sort of things people are doing with FHIR. So there's an example of 3 of them. We support them, and for people that have been using IHE and HealthShare, they'll find themselves on very familiar ground. It's basically the same basic rules of the road, same message classes, but because FHIR brings some new stuff, then Matthew's team built some new services and operations in HealthShare to support that efficiently. Let's talk about the future. So for folks that follow the FHIR standard, draft standard 2 was sort of been around for the longest, and standard 3 just came out. So we're working on providing support for standard 3. But as I tell people, if you have something you want to do with standard 3, like for example, someone wants to send you a JSON document that's standard 3 compliant, don't let that stop you, because like I did a project where standard 3 comes in and I just pull out what I need, right? So you guys know how to use stuff in HealthShare. You know that give me something electronic and I can use the modeling and the scripting capabilities with HealthShare to get what I need out of it. So if you have a need to do stuff in Stu 3 right now, even though the support for that's coming, don't be shy, ask your sales engineer and help, because there's the framework for working with these JavaScript documents is there, and there's no reason why you can't make progress until Stu 3 becomes available for you. And once Stu 3 is available, you're going to have the mappings between HealthShare's canonical data form SDA and Stu 3, and then we're also going to provide a way for people that built stuff on draft standard 2 to get progress within standard 3 without having to go and start all over again from scratch. But these are mappings. Now, for people that are familiar with summary document architecture, you'll know it's broken down into clinical sections. So there's a set of those. But then if you go and look at the FHIR standard, there's a set of those. There's a whole lot. So you've got SDA and you got FHIR. So what Matthew's team is working very hard on is to try to improve the parity between them, so that for people that are maybe ingesting FHIR and they want to get into SDA form, that the parity between the two is a little bit tighter, and also that for mapping between one, that there's some tools to help you do that work. And so that's kind of the future of FHIR and InterSystems. So forget everything your parents told you. Get out there and play with FHIR. There's a lot of stuff out there that if you just want to play, like that that app gallery, you can just go there and run it. It's all browser based. You can play around with it. As I mentioned, we had sessions here. They're going to be available as recordings. But you can do things like start to learn a bit about FHIR. I love the HL7 FHIR site. They got tutorials. They tell you why things are the way they are. Because sometimes when you read your standards, you're like, I thought I understood this. Then you introduce that thing, and I don't get it anymore. But they learned from everything that's come before them. And in terms of trying to teach people about FHIR, I can't see how they could have done a finer job. The examples in different data formats. They got tutorials, excellent explanations. There's forums. And then there's ways to connect with other people that are trying to maybe figure out how they're mapping something in their EMR to FHIR. So there's great communities out there as well. So here are some resources that are provided by the learning team at InterSystems. You can go online and find some really nice high-level stuff about FHIR. And then there's going to be some things to help you learn things more in depth for working with FHIR and HealthShare. And then apart from that, again, because HealthShare is compliant with Smart on FHIR, when you go out there and find applications to Smart on FHIR, you can now begin trying to use them in HealthShare. And if you, again, watch Gary's section, you can learn about that. But Please work with your sales engineer once you get a sense of what you'd like to do with it, so they can guide you to the right learning resources and some things that are out there in the field, and then you can start playing with FHIR and not get burnt. Okay, so I hope you'll complete the session. If you didn't enjoy this session was called FHIR Gateway by Gary Munger. But no, I'm just kidding. But no, this has been Smart on FHIR, the basics. So I hope you'll fill out the survey and let us know what you think, because the gentleman that runs learning services at InterSystems, actually some of the teams in the back, and they are extremely committed to making sure that you can learn how to do new things with our technology in InterSystems. So as you fill out the survey, you don't need to limit yourself to just talking about this session. If you have any suggestions for them, please include those as well, because they will see them. And so I thank you very much. There's a little bit of time for questions. Thank you. If you have any questions for me, I'll be around. If you have any questions for learning services, there's just no rest for you guys. So if you have questions for them, they're right in the back as well. Thank you very much.